Good day, Philo. Setsu is back. Today, I just want us to do this concept of chemical bonding. See now the concept of chemical bonding. See, as a learner, you need to know the definition of chemical bonding. It is as follows. It is the electrostatic force of attraction between atoms. See now, holding them together. You see, like this. It is an electrostatic force of attraction between atoms, holding them together like this. You see, don't be confused by the term electrostatics. You see, electrostatic. The term electro, it has to do with electric charges. You see, we know from chemistry or physics that we have three of them. We have protons, electrons, and neutrons. You see, these ones, they are positively charged like this. Sorry, these ones, they are negatively charged. Then we also have the last one. This one we say they are neutral, like this. You see? Then now, what I'm going to do is, in a chemical bonding, we just need to know that electrons are involved in a chemical bonding. You see, the electrons are involved in a chemical bonding. And do you still remember that we have three types of chemical bonding? We have a covalent bonding, you see. We also have an ionic bonding. Thirdly, we have a metallic bonding. You see, briefly, an ionic bonding takes place between non-metal, two non-metal plus non-metal. You see, then in ionic bonding we have a metal plus a non-metal. This one we have a metal plus a metal in a metallic bonding. For the sake of today, we are mainly going to focus on the covalent bonding. You see, since I don't have much space, let me just erase. We are going to focus on the covalent bonding. Covalent, let me write covalent bonding like this. See? Then it occurs between a non-metal plus a non-metal. You see? Then it also states the sharing. See? The sharing of electrons now. Electrons between atoms, mainly non-metals. See? Mainly non-metals. Which are those electrons now? Which are those electrons that are sharing? You see? We call those electrons the valency electrons. What are those electrons now? We say the valence electrons are electrons in the outermost energy level. Outermost energy level. Do you understand? Like this. Then now you need to understand something, that in our periodic table we have elements in group 1, we also have group 2, group 13, we have 14, group 15, 16, group 17, and let me just also add 18. See, then you just need to know that all the elements in group 1, they have a valence electron of 1. You see, they have one valence electron. The example that I can use here is hydrogen. Hydrogen is given by H with one valence electron in the outermost energy level. Then now we also have group 2. These ones, they have 2 valence electron. Then the example that I can give is beryllium. You see, Be, like this. You see, they are like this. Then thirdly, in group 13, they have valence electrons of 3, like this. An example that I can give is boron, like this. You see, something like this. Then group 14, we have the valence electrons of 4. An example that I can give is carbon. Let me write it here. It's something like this. You see? Then in group 15, we have, I think we have a nitrogen. Yes, we have nitrogen, which can be given by, we have 5 now in outermost energy level. Then in group 16, we get oxygen. You see, an example that I can give is oxygen, which can be written in this format. The valence electron for oxygen. Then group 17, we have chlorine, like Cl. There's 7, something like this. You see. Then lastly, we have the noble gases. Mostly they have 8 electrons in outermost energy level beside helium. Helium, it has only two. You see, it has only two valence electron, but neon, it consists of 8. This is an exception, you see, but neon, it consists of 8 valence electron. He is just an exception, you see. Then all the elements in group 8, they are stable, you see. Somehow they don't need to share because their outermost energy level is full. Then now these numbers, they represent what? The valence electrons of elements in group 1 till group 18. Then now I'm going to avoid this one because now we say it is stable. All group 18 elements, they are stable. Now I'm going to focus on group 17, 16, like that. Then you just need to know that all the elements that are situated in group 17, they are going to have a single bond. Then we move upward. These ones, they are going to have a double bond. This one, let me just say 3 bond. Then as for group 14, they are going to have 4 bond like this. Then as for group 1, group 2, and group 13, this one, they mainly going to consist of 1, this one 2, and this one 3. You see? Then this side, it represents the number of bonds. The number of bond. See? Bond. Then this side we have what? The valence electrons in outermost energy level. You see? Now what I'm going to do is, suppose if I were to give you this example. Let's say if I were to give you this one. Let's say if I give you, let me start with number 1 with H2 and ask you this question now to say, draw the Lewis diagram for H2. How are you going to draw the Lewis diagram for H2? It's so simple. How many hydrogen do we have in this given? It's so simple. We have 2. Then if we go to our periodic table, we know that hydrogen is situated in group 1. That means it is going to have what? 1 valence electron. Firstly, you can start by saying, separate those hydrogen. We have 1 of this. Let me write single dot like this, then plus another one like this. Let me put X. You see? Then these 2 hydrogen, they are going to combine. You see, they are going to combine in such a way that each, let me say this dot with X, they are going to combine to form something like this. You see? Now they are going to pair with one another in such a way that they join together in a form of a dot with an X like this. Now we can see that the hydrogen, there is a chemical bond between the 2. You see, at first we had one each with another one each, but now they are combined in this situation, you see. And another thing that I just want to highlight to you, my fellow, is that two electrons, you see I have two electrons, they form a single bond. You see, other learners would write this one like this. See, two electrons, they form a single bond like this. You see. Now let me just take a second example. Let's say if now we had my apology about the light. Let's say if we had chlorine, let's say Cl2 like this. Then now how are you going to draw the Lewis diagram for this given Cl2? So simple. Let us separate them firstly by saying we have Cl like this. We have 1 2 3 4 5 6 7. Why? Because chlorine, it is situated in group number 17. The valence electrons of Cl, they are going to be 7. Then now let's write plus. We have Cl, another Cl, then we make X like this. You see? Then what is going to happen now in this situation? We can clearly see that we have one unpaired. We also have one unpaired. That means this dot is going to pair with this X. See, this dot is going to pair with this X in such a way that now we get something like this. We have Cl 1 2 3 4 5 6 7. You see, then it's going to pair with this Cl now such that they form a dot with an X. You see, it's so simple like this. Now we get a chemical bonding between Cl together with another Cl there. Then now let's go back. You see, we have 7 valence electrons for each Cl, but now as for bond, we are going to get a single bond between Cl and Cl. Two electrons, they form what? A single bond like this. Cl, Cl. You see, this side we have X. You see, let me give you another example. Suppose if now I have, let me give you oxygen. Let me give you O2. Suppose if now we have, let me write number 3. Suppose if, let's say we have O2. You start by separating them like this. Then oxygen, it is situated in group number 16. That means it's going to have the valence electrons of 6 like this. Plus we have, we have X now, X, 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 X. You see, 2 oxygen like this. Then now we need to pair them now. How are we going to pair them? We can clearly see from our diagram that this one together with this one, they are unpaired. Same as this X and this X is unpaired. One of these is going to be paired with this, then one of these is going to be paired with this one. You see, at the end of the day, we are going to get the situation which is like this. You see, one of these is going to pair with this. Let me write X. Then one of these is going to pair with one of these, like this. Then now we get a situation which is like this. You see, from this we can clearly see now, since from that given which I gave you, that if we have all the elements in group 16 with the valence electrons of 6, they are going to have how many bonds now? 2, like oxygen. We can clearly see that now between oxygen we have 4 electrons. For 4 electrons we are going to have what now? The double bond, which means now for 2 electrons we are going to get a bond. For another electron, same, we are going to get a bond like this. At the end of the day, we are going to get something which is like this. Do you get the point? Then now, let us continue. Let me give you this one now. Suppose if I were to give you this one, NH3 NH3. You see, now we have a nitrogen together with what? With hydrogen. On our periodic table, nitrogen, it is situated in group 15, which means now the valence electrons for N going to be 5. We are going to get a situation which is like this. We are going to have 5 of valence electrons. Then how many H do I have now? 3. I have 3 hydrogen. Let me write X plus, let me write another hydrogen like this, plus another hydrogen like this. You see, how many unpaired electrons do I have in this given? I have 1, 2, 3. You see, then how many hydrogen do I have? 3 of them. That means this electron is going to be paired with this, then this electron is going to be paired with this, then the last one is going to be paired with this one. At the end of the day, I'm going to get a situation which is like this. Now I'm going to, sorry, I don't have much space. I'm going to get a situation which is like this. You see, I have 3 of this. Then I'm going to put X for this H. Same here, X for this H. Same X here for the last H. Then now, I want us to focus on this given diagram, which I drew right now. Check. If you were to look carefully, nitrogen, it is situated in group number 15. You see, it has 5 valence electrons. Then as for the number of bonds, we are going to get a situation now with 3 bonds, and which is true. Let us check on our diagram. You see, for dot and X, we are going to get a bond like this. Same for X and dot, we get a bond, another bond like this. Same as for this one, we get another bond like this. Then these ones, we call them lone pair, lone pairs, called like they are not paired. You see, unpaired electrons, we call them lone pairs. You see, like this. This is the Lewis dot diagram of what now? Of NH3 with 3 bonds like this. You see? Then let us continue. Let us continue. Now, let's say if I were to give you this diagram now. Sorry. This formula of CO2. We know that carbon is situated in group 14, which means it's going to have 4 valence electrons, plus we have 2 oxygen. Each is going to have 6. We already know for this one that is situated in group number 16, plus another O again like this, number 16 like this. I don't have much space. Let me write it here. I'm going to write it somewhere here. Now we have a situation here. We have carbon together with oxygen. Now we want to know which element is going to be situated in the middle. You see, it is so simple. The one with most number of bonds, it is going to situated in the middle. Like now in this case, let's go to this let me just say a table. You see, carbon is situated in group number 14. Then it's going to have 4 bonds, but oxygen is situated in group 16 with 2 bonds, which means this one is going to be in the middle now. See, in the middle like this. You see? Then now let us check. We have 4 unpaired electrons, sorry, for carbon, which means this one is going to pair with this. This is going to pair with this, you see? Then one of these is going to pair with this. Then the one of this is going to pair with that one, you see? At the end of the day, we are going to get a situation which is like this. One of these with this one, let me just put X like this. One of these electron is going to be paired with this X. Then I have O like this. Then this side, I'm going to have something which is more similar to this one. One of these is going to pair with this X. One of these is going to pair with this. Then I get O like this, which is X, X. See? It's so simple. Let us go back to our table now. Check. For carbon, we get 4 bonds, and which is true if we were to check here. By saying now 2 of these going to represent a bond, 2 of these, it's another bond. Same here, going to get situation which is like this. Then now I draw, let me just put X, see, like this. You see, I have double bonds in between now, you see. Then it's not difficult, isn't it? Okay, now what I'm going to do is, suppose if I were to give you now this one, let me erase because I don't have much space. I don't want to remove this one. You see, what I'll do is number 7, I give you water. By now we know that H is going to have 1 valence electron plus another H, 1 valence electron, oxygen 6, like this. You see? Then one of these pair with this one, then this one is going to pair with this one. At the end of the day, oxygen group number 16 with valence electrons of 6, it has 2 bonds, but hydrogen, it has 1 bond, which means O is going to be situated in the middle like this. See, like this. Then 1H this side, 1H this side. Then you see we get a situation which is like this. If I were to represent the bonds, I would say now we know for oxygen is going to have how many bonds? 2. This one, first bond, O, this side, another bond like this. See, then I just put X like this. You see, we get a situation which is like this now. You see? Then lastly, we have a special case which is like this. Which is like this. NH4 plus. NH4 plus. You see? This is a special case that we have. We know that nitrogen, it has 5 valence electron like this. Then we have 4 H's plus. This is a special case. You see? Like this. Then, in this case, we can clearly see that we have how many unpaired electrons for nitrogen? We have 3 unpaired electrons, which means we are going to get a situation which is like this. Then this H is going to be paired here, then a dot. This H is going to be paired somewhere here, yes. Then we have a dot. This H is going to be paired somewhere here like this. Then now, what is going to happen with that last H? Now we get a situation which is called a dative bond. You see, a dative bond, whereby those lone pair of what? Of this nitrogen, they are going to be paired to that remaining H. Now we are going to get a situation which is like this, which means those 2 electrons, they are going to be used to form a bond, which is a dative bond. You see, now we call it a dative bond when the lone pairs like this one, they form a bond now with what? With that remaining H, since they were 4 of them. But now we should keep this in mind. We should keep this in mind, that addition. You see, that addition, we must put that addition like this, because now if we were to represent this given diagram in a form of lines, we would say now, in a form of bonds per se, we would have a situation which is like this. You see, like this. Because this one is a special case, we just put an arrow to indicate that it is a dative bond. You see? Then now I want to show you where does this plus charge come from. You see, we call those focal charges. You see, it is given by focal charge, it is given by number of valence electrons plus minus the number of bonds plus dots. You see, which is like this. How many valence electrons do we have for the middle, which is nitrogen? We know we have 1, 2, 3, 4, 5 valence electrons. Then we write 5 minus. Then how many bonds do we have now? We have 1, 2, 3, 4. We have 4 of these. Do we have some remaining dots there? No, we don't have any dots. All in all, we have lines like this. We don't have the remaining dot. Then now we just write 0. If you were to take your calculator and say 5 minus 4 plus 0, then your final answer is going to be 1, which is plus 1. You see, this plus 1 is this one. You see, but there is no need for us to know this. You see, I just wanted to show you where does this plus 1 come from. You see, then just like this, we have managed to complete the entire concept of the covalent bonding. And I thank you and enjoy fellow.